In this lesson, we're going to continue to look at molar calculations. These problems are going to be slightly harder than the previous lesson. We're going to determine the mass of a product produced during a chemical reaction. In this case, we're going to find the mass of magnesium oxide, which is produced when 20 grams of magnesium burns in oxygen. Now, the first thing we have to do whenever we have a problem like this, always, is to write out the chemical equation. So we know we have magnesium and it's going to burn in oxygen, and the product is magnesium oxide. So you need to know the formula for magnesium oxide, and the next step always is to balance the equation. So we look to this side and we see, well, the magnesium's okay, but oxygen isn't. We've got 2 oxygen atoms this side and 1 oxygen here. Now, you know the rules. You're not allowed to do that because that's changing the formula of the compound, and we're not allowed to do that. That is not the formula for magnesium oxide. That is. And so to balance the equation, we need to put a number in front of the compounds or elements in the equation. So we're going to put a 2 here, and that sorts oxygen out, but now we've got 2 magnesiums and 1 this side, so we need to write a 2 here. So everything is fine. Now these numbers here, the 2 here, the 1 here, and the 2 here, are the molar relationships in the reaction. These tell me that for every 2 moles of magnesium, then 2 moles of magnesium oxide will be produced, and I need to know that. So the next step is to find out how many moles exactly of magnesium I'm burning. So I need to know the relative atomic mass of magnesium. Okay, the AR for magnesium is equal to 24, and then I do my rule of 3. I say 1 mole of magnesium has a mass of 24 grams, then how many moles is 20 grams of magnesium? I cross multiply. I say 1 times 20 is equal to 24 times x. Solve my equation, and that gives me x is equal to 0.83 moles. So what we're saying is 20 grams of magnesium is 0.83 moles. Now going back to our balanced equation, we can say that if 2 moles of magnesium produce 2 moles of magnesium oxide, then they are in the same ratio. That means that 1.5 moles of magnesium will produce 1.5 moles of magnesium oxide, or 20 moles of magnesium will produce 20 moles of magnesium oxide, or, as in this case, 0.83 moles of magnesium will produce 0.83 moles of magnesium oxide. So we can write that down here. We can say 0.83 moles will produce 0.83 moles of magnesium oxide, because the molar ratio is the same. It's 2 to 2, 1 to 1, 0.83 to 0.83. Right, so the last thing we've got to do now is calculate the mass of magnesium oxide produced. To do that, we need to know the relative formula mass of magnesium oxide, which is equal to 24 for magnesium plus 16 for oxygen, gives us 40. We write out our rule again. We say 1 mole of magnesium oxide weighs 40 grams. That's what the relative formula mass means. Then 0.83 moles will weigh how many grams? We cross multiply. 1 times x is x, is equal to 0.83 times 40, which gives us 33.33 grams. Okay, let's have a look at another calculation. This time we want to know the volume of sulfur dioxide that is produced when 10 grams of sulfur burns in oxygen. Again, we write out our equation. We have sulfur burning in oxygen produces sulfur dioxide. That's a simple equation. It's already balanced, so we don't need to touch anything in that. It's a 1 to 1 to 1 molar relationship. That means that 1 mole of sulfur will produce 1 mole of sulfur dioxide. 10 moles of sulfur will produce 10 moles of sulfur dioxide. 0.785 moles of sulfur will produce 0.785 moles of sulfur dioxide, etc. So what we've got to work out now is how many moles of sulfur do we have? Well, we're told we've got 10 grams of sulfur. So the first thing we do is we find the relative atomic mass of sulfur, and that's equal to 32. We look to the periodic table for that, and then we make our molar statement again. We say 1 mole of sulfur atoms weighs 32 grams. Then how many moles weighs 10 grams? We cross multiply. 1 times 10 is 10. 32 times x. Solve the equation. X will be equal to 10 divided by 32 equals 0.31. It's 125, but we'll leave it as that. 0.31 moles, okay, of sulfur. So from our molar equation we can say that 0.31 moles of sulfur will burn in oxygen to produce 0.31 moles of sulfur dioxide. What we want to know now is how many litres is that? What is the volume of that amount of sulfur dioxide? Because I should have put this here, sulfur dioxide is a gas. It's not a solid. So I need to state my gas rules here that 1 mole of any gas, no matter what it is, whether it's sulfur dioxide, argon, helium, hydrogen, doesn't matter, of any gas occupies a volume of 24 litres. That's 24 decimeters cubed at room temperature and pressure. Okay, so I ask myself, if 1 mole occupies 24 litres, then 0.31 moles will occupy how many litres? X litres. Cross multiply. X times 1 is X. 0.31 times 24. And that gives me 7.5 litres.